This is a quick video with just showing the examples that you asked to be done. In problem number 7, please notice that both of these terms have the same base. They're both log base 10. So we can condense those two logarithms into one logarithmic statement. And then we can, which is in multiplication, since this was an addition, we multiply the two arguments. And when we multiply the two arguments, we get 3x squared plus x minus 14. Now we think of this as it's log base 10, so we're going to write that with the base to the power of 1. So this is, you get your base, you get your exponent, and then you have what it equals. So we've written the equation, and now we're just going to set it equal to 0, factor to solve. But with this first factor, we'd have x equals negative 3. The other one, x equals 8/3. The x equals negative 3 would give us a negative argument. So if you placed it back up in here, you're going to get negative 5, and you can't have a negative argument. This would also be a negative 2 when you plugged it in here. And so you can't use x equals negative 3. It's extraneous. The only solution is x equals 8/3. In problem number 9, it's the same idea. Please note that both of those are logs of base 10. They're the same base. Since we're subtracting these two logarithmic expressions, we get to divide the arguments, and the one that's positive that we're adding this logarithm, so its argument goes in the top. And since we're subtracting this logarithm, the argument x minus 2 goes in the denominator. And then once again, we notice this is base 10, so we're going to write it in exponential form. 10 to the first equals this 5x over x plus 2. So now we're just going to solve that algebraic equation, and by multiplying both sides by x minus 2, distributing, subtracting the 5x from both sides, and then adding the 20 to both sides, dividing by 5, and you get x equals 4. X equals 4 works just fine in both of these arguments, doesn't give me a negative argument, so that's the answer. Number 11. Now this one's a little bit different. It's an exponential equation, and our first step would be, could we write both the left side and the right side with the same base? We cannot in this problem, so the next step is then to take logarithms of both sides. So I'm going to use log base 10, and I'm thinking about in the future I'm going to be using my calculator. So use a log that has the base that's on the calculator. This is slightly different than the way that I did it on the solutions sheet. Also, there was an error, as was noted in class, on that solution sheet anyway. But this time I'm going to just use log base 10 of both sides. And recall that for this one here on the left, that the exponent now comes out in front. That's one of our identities of logarithms. So we have 5x plus 1 out in front. Remember that this here, this log base 10 of 3, this is just some number. If you plug it in your calculator, you'll know what the number is, or you'll know an approximation of that. But it's just a number, so I'm treating this log base 10 of 3 as a number. Everything I can do with a number, add, subtract, multiply, and divide, I can do with that whole expression, log base 10 of 3. So I'm going to divide both sides by log base 10 of 3. And then I have this equation, and here I'm trying to solve for x. So I would subtract 1, and then later on I'm going to divide by 5. So there I subtracted 1. Now I divide by 5. And now you just need to put that in your calculator. And that might be the hardest part of this at this point, is to how do you plunge that into your calculator? Well, these are the keystrokes, and the big problem here, the thing to note here is all of these parentheses. You got to make sure you use enough parentheses. So I color-coded them so you can pause this and look at it more carefully. Next problem. This one was just basically plug this in your calculator, and you go, well, I don't have log base 5, so we have to use the change of base formula. And remember that you could either use log base 10, or you could use the natural log, ln, but I used log base 10 here. And you always have the argument of the original one, so 17 was the argument. That's now log base 10 of 17 is in the numerator, and the old base, which was 5, is now the argument of the denominator, so log base 10 of 5. And again, you just plug that in your calculator. I don't have a calculator with me to find these answers rounded to, I think I had asked you to round them to like 3 decimal places or something. So you'll have to plunge that in your calculator. Number 17. It starts off looking confusing because you see all these logs, but if I just blocked this thing off, don't look at it, and I say, okay, write that other problem in exponential form. Remember, it's right here. We got natural log here. Don't look at this one in the middle here. We have the natural log of something equals 2. So writing that exponentially, well, that's e squared equals what was, what this is. This is this argument. This is the value they put here. And now remember that e squared is just some number. And if I had some number here, we would look at this and we'd say, well, since it's base 2, and then go, well, maybe it's the direction you're looking at. So let's rewrite it in the other direction. I just flipped it here. If I look at this, we say, oh, let's write this exponentially. The base is 2, and over here is the exponent. This e squared is my exponent. So I've got 2 to the e squared, which means we just need to put 2 to the e squared in our calculator. Well, there's the keystrokes once again. So plug that in your calculator and you'll know the approximate value. For number 28, notice that all of these are log base e. They're all the natural logs. So we're going to do a little bit of identity work here. First of all, these coefficients go up and become the power of the argument. So we could write it that way. Now, since they're all the same base, all of those are natural logs, we're going to combine these arguments, and if I'm adding the logarithm, then this is going to go in the numerator of the argument, and here this is going to go in the numerator. Here I'm subtracting, so this argument's going to go in the denominator. So I start off with this, I know I'm going to have a fraction, and all of those arguments where I was adding are in the numerator, all the one argument that was in the denominator. And I just simplified that. You got 5 squared, so it didn't distribute it. And so you've got 25x minus 25, and the denominator, the x plus 2 quantity squared, I just expanded it out. So this is an explanation of the problems you asked for. There's a couple of the graphic one. I'm going to make another video in a few moments here, but I wanted to get this one off to you.